for introducing me, Andy, and I can only echo Andrew's comments really about what a pleasure and privilege it is to be speaking here before the campaign and to have a sort of long-term historical association, seeing the campaign grow and its expanding importance. Of course, in a perverse sense, we would prefer for the campaign not to exist, or rather not to have to exist, because we would like to see less anaphylaxis around. And one way of diminishing anaphylaxis, particularly in children where food allergy is the leading cause, would be to try and prevent food allergies. So, without further ado, I'm going to talk about the LEAP and EAT studies. I think I'm meant to be talking from here, am I? Yeah, I'm just trying to work out the logistics. I see. I can stand here and see the screen. Perfect. Sorry? Yeah. Okay, yeah. Am I sort of vaguely visible and audible from here? Okay, well, you'd probably prefer less visible and more audible, but so I'm going to talk about the LEAP study. I always now, when I talk about the LEAP study, emphasize a conflict of interest issue. I'm not terribly good with the social media, but when the LEAP study was published, there was some twittering or blogging or whatever one calls it by a guru who does that for her living in the United States, saying that the study was corrupted because it was all serving the interests of peanut farmers. And I'd like to dissociate myself from that claim whatsoever. It is true that we have received funding from the National Peanut Board, which is regulated by the agricultural group in the United States, which is a governmental group, but no funding was received for the LEAP study, and the LEAP study was run by the Immune Tolerance Network, which is direct funding from the NIH, which is government money in the United States. So I'd like you to rest assured that we don't represent sort of Jimmy Carter's family and his friends in Atlanta, although they're pleased with the results of the study, needless to say. So I'm going to give you a brief background and overview with the results of the LEAP study. We had prematurely promised the EAT study, which is currently in the throes of analysis, and we should have results for you very soon. Those are going to be submitted for publication towards the end of the year, and we hope to have appeared in the press sometime early 2016, February, March, hopefully April at the very latest. So unfortunately, I can't talk about those results today. So, background is, many years ago, I gave a talk in Tel Aviv, in Israel, to an audience roughly twice this size that comprised mainly pediatricians and pediatric allergists. They'd asked me to talk about peanut allergy, so I thought a starting point would be, for a show of hands, how many of you have come across a case of peanut allergy in the last year? Actually, why don't we do it here? How many of you have come across a case of peanut allergy in the last year? Okay, so this is pretty much an overwhelming majority. Of course, we have a skewed, we have a slightly skewed audience today, so it's not the most scientific experiment we just conducted. But in Israel, you had the pediatric allergists, all the pediatric allergists there, and the pediatricians, and out of a group of 200 people, 3 people put up their hands in the audience, which didn't really seem to make sense. They couldn't have been missing the diagnosis. Most of them had actually trained in the United States, where peanut allergy was on the rise, and they were trained to look for and diagnose peanut allergy. So it occurred to us there might be a true difference. That didn't make sense in, well, it seemed to go against the fact, for a while we thought, well, maybe it's something to being of Jewish background genetically, ancestrally, but in London, in North London, there's a very large Jewish population. We saw a lot of peanut allergy during those years in those children. So it didn't really make sense from that point of view. So we first decided to investigate this epidemiologically, and we looked at about, together with George Dutoit, who you know well, who was in South Africa at the time. He came over to join me, and we worked together with Dr. Itzhak Katz in Israel, comparing 5,000 children in the UK, 5,000 children in Israel, and indeed we found that the rate of peanut allergy. Now, is there a pointer on this? No, it's not working, doesn't matter. But you see the big orange bar there was 10 times higher in Israeli Jewish children than in UK Jewish children. And this, we felt, could not be accounted for by ancestral or genetic differences, because these two groups of children share common ancestral heritage. We looked at various environmental factors, and one thing that really stood out like a sore thumb was the fact that at the time in the UK, the recommendations were avoid peanuts, particularly in high-risk infants, but that was the norm across the population. And as you can see here, the median consumption or average consumption of peanut in the UK in children in the first year of life or so was 0 grams per week, whereas in Israel, per month, I beg your pardon, whereas in Israel it was 7.1 grams. This is grams of protein, so you multiply it approximately by 4 to 5 times to get grams of peanut, so about 30 grams a month in Israel versus 0 grams in the UK. What was also apparent was, this raised really the question as to whether early introduction in the first year of life of foods, rather than cause food allergy, which we had all believed for a long time, may actually prevent food allergy. And going back to my days as a laboratory researcher in Denver, back in the late 80s and 90s, it always struck me then that we were working on food allergy models in the laboratory, and we were making mice become allergic by rubbing egg or peanut on their skin, especially if the skin was inflamed, and that would lead to allergy. I tried very foolishly as a young researcher to start experiments without really reading the background literature, and I tried to make mice allergic by feeding them peanuts, and I found that was, not peanuts, but egg, which I was working on at the time, and found that that was impossible. And the reason that was impossible is for decades it's been known that if you take a young mouse pup and you give it egg or milk, and now there's evidence that if you give it peanut, you actually induce long-term tolerance and you prevent the development of allergy. And when I found that out from the literature and my failed experiments, it sort of dawned on me that at the time, although they were not in official guidelines, pediatric allergists and pediatricians in the US were very much in the mode of avoidance of allergens, egg, milk, peanut, fish, shellfish, in young infants to prevent the development of food allergies. And it also always occurred to me rather perverse that we were advising mouse families different from human families. So we were giving mice foods very early on to prevent allergy, whereas in humans we were doing exactly the same. We were avoiding the foods. So at any rate, we, based on the LEAP premise, based on some of these background thoughts, we did the LEAP study, which now was started to be planned about 11 years ago. We then did a feasibility study for about a year to a year and a half, and this was a 5-year study with 2.5 years of recruitment. So this has been going on for ages, hence the grey hairs in myself and loss of hair in my colleague George, and though please don't quote me on this, but it has been a long study because we had to follow children from 4 to 11 months of age to 5. And we chose high-risk children, children with a high risk of developing peanut allergy, who had severe eczema or egg allergy in the first year of life, as young as 4 months of age. And we randomly distributed them into 2 groups. One, the grey group, was prevented from eating peanuts from the first 5 years of life with careful dietary advice and monitoring, initially at 2 weekly intervals. The other group was advised to eat at least 6 grams of peanut protein per week, and we followed them till the age of 5, and using a double-blind, placebo-controlled peanut challenge, which I believe most of you are familiar, where you incrementally feed doses of peanut, where you don't know whether it's peanut or placebo, you observe for objective signs of allergy, lip swelling, hives, vomiting, etc., symptoms which you're all very familiar with. Now, the idea was, when we enrolled these children, that we would be getting them early on before their peanut allergy developed. And what was very interesting to us, actually, was that there was a large... So we did skin testing on all these children before half of them received peanuts. This was really for safety reasons, just to prove that they were not allergic yet. But of the 640 children enrolled in this study, 98 of them already had small positive skin tests in the first year of life. So they weren't allergic yet, the vast majority of those, but the process of becoming allergic had started. They were what we call sensitized, and we actually had to exclude 76 children from the study because they already had pre-existing peanut allergy with huge wheals. So if they had a wheal 5 millimeters or greater, they were deemed to be peanut allergic, and we didn't put them in the study because this study was about prevention, not about oral immunotherapy to treat peanut allergy, which you're aware of. And yeah, this study needs, it's very clear here that we distinguish between the concept of prevention and treatment. So we collected blood at various time points, we did skin prick testing at various time points, and I just want to show you, group 1 were excluded from the study. They phoned in, but they didn't have enough. They had no eczema or very mild eczema, no egg allergy. Group 4 are the 76 children we excluded because of pre-existing peanut allergy. Group 2 and 3 were enrolled into the study. Group 2 are the children whose skin tests were negative to peanut, who we thought were sort of immunologically naive to peanut. They had a skin test of 0, and they were 542. The numbers are slightly different here because we didn't have IG measurements on all of them, and this is showing IG. Group 3 are the 98 children who had small skin tests, who largely were not peanut allergic at the entrance into the study. So we had an opportunity to see whether you could prevent peanut allergy in group 2, who had negative skin tests, and prevent peanut allergy in the 98 children who'd already started to become peanut allergic but weren't quite there yet, who were further along the path towards allergy. Now, they ate largely either bamba, this Israeli snack, or peanut butter, and they were asked to eat 2 grams of peanut protein 3 times a week. We didn't actually quite put it in those terms, as you can imagine. The dietitians gave them practical advice, and there was careful avoidance given to the avoidance group, and we kept reinforcing this advice through the study. The actual consumption in the consumption group was higher than we had actually requested. So infants, and again, I'm not talking on behalf of the peanut farmers, but actually, surprisingly, infants, I wouldn't have intuitively thought that was the case, but infants really liked the taste. How do we know that the families were really giving their children peanuts? One of the things when you participate in a trial is you work very hard, it's a big thing, and one of the things is families like to please the researchers. I'm not for a moment saying they will lie, but there are various, recall, especially if you're writing down what happened over the last week, can be slightly biased. So what we did, we used an objective measure of what they were eating by measuring peanut molecules in the dust of the baby's bed, which sounds like a crazy thing to do, but it actually works. And Helen Bruff has shown in separate studies that there's a very nice correlation between the amount of peanut you measure in the dust in the bed and what that person who sleeps in the bed is eating. And there's a huge increase in the peanut consumption group this is bed dust. This is a log scale, which means that 0 to 1 is a 10-fold increase. So essentially, they were eating 30 times as much peanut in the peanut consumption group as the avoidance group. And here are the clinical outcomes. This is just to show that the vast majority of diagnoses were made on the basis of challenges. And the question was, which is the better strategy, to eat or not to eat? This is a 6-month-old who I'd observed many years ago in Israel eating bamba. And what we saw was an 86% reduction in the children who were eating in peanut allergy, in the children who were in the consumption arm, going down from 13.7 to 1.9%. That's in the skin test negative group, in the children who hadn't started the allergic process. And against my predictions, certainly, and to my great surprise, we found a similar level of reduction in the children who'd already started to become allergic. They were sensitized. I thought it would be too late, but we found a 70% relative reduction in the rate of peanut allergy. So we could prevent most of the cases of peanut allergy in both groups. And of course, when you combine the two groups, you get an average effect. One of the questions was, and actually what I don't know whether you noticed, when I showed the various groups, the group who was excluded, then group 2, the children who had a negative skin prick test, what I hadn't pointed out in that slide was already close to 30% of them had IgE levels to peanut that were detectable at greater than 0.1, and 17% were greater than the traditional higher cutoff value of 0.35. So even the children with negative skin tests, many of them were already making allergic antibodies to peanut. And we wanted to know whether this worked in children who had no antibodies to peanut as well as in children who did have antibodies to peanut. So we were able to separate out the groups. And if you look on the extreme left panel, those are the children who were skin test negative and IgE negative to peanut. And you find in those 378 children who were a subgroup, it still works. So basically, this seems to work if you are negative on skin test and negative on IgE. It seems to work if you are negative on skin test and positive on IgE. It works if you are positive on skin test and negative on IgE, and it also works if you have a positive skin test and IgE. So whatever the constellation of sensitization, so long as you're not yet peanut allergic, this seems to work, which was very gratifying and to me a great surprise. One of the questions that the reviewers had asked us when we'd handed this in was, well, what about the children who were not Caucasian? Because if guidelines are going to be changed as a result of the study, and people are still considering that, that might need to be instituted in different parts of the world, and maybe this only works in a Caucasian population. And the luck of, the advantage of working in London is because we have a multi-ethnic community, we were able to look at the 25% of children who are not Caucasian, who are of Asian origin or Afro-Caribbean origin, and we found very similar levels of reduction. What you may notice, and that's an aside, but quite an important one, I think, for the anaphylaxis campaign to note, is this study and others have shown that the rate of, so you've got mixed ethnicity, Asian and black, and compare that to the white or Caucasian group on the left. If you look at the gray bars, you find that the non-Caucasians have much higher rates of peanut allergy. And in fact, there's a lot of evidence too from the US showing that non-Caucasians have much higher rates of food allergy. And they are a population we particularly need to target because they share a disproportionate burden of allergic disease. But the good news for us, and for them, hopefully, is that this seemed to work in all the various groups. All the data on the trial is available online, and you can go into www.itntrialshare.org, and if you like, actually, all the raw data is there. You're free to reanalyze it yourselves. I'm going to briefly go over adverse events. I'm sure many of you will want to address that during question time, but serious adverse events were the same in both groups and not related to peanut consumption. adverse events are also shown online. There was a slight increase in skin adverse events in the consumption group, which were transient in the first year of life, which may have been related to perception of worsening of eczema or true worsening of eczema. We don't know for sure because this study was not a blinded study in the sense that we didn't have a placebo. It was impossible to recreate this Israeli peanut snack without putting peanut into it. We'd looked into this initially, but that wasn't really an option. I'm going to go to some of the I'm going to talk about the safety of the challengers. Okay, well, we all know challengers can be a risky business, and it should be noted that in this study, at 60 months of age, when the children were 5 years old, there were 57 positive challengers, and as expected, a number of them actually had quite severe reactions and required the use of injectable adrenaline. 9 children required adrenaline, that's probably because actually they were highly atopic and they were selected on very severe eczema. This was a highly atopic population. So what about growth? One of the big criticisms, questions, concerns about this study, here we are taking a fast food and loading babies up with it, and what are we going to do to their diet and nutrition and growth? Will we be causing obesity? Will we be causing a macro or micronutrient imbalance? So we looked at growth, and you can see that weight is identical between the two groups at all the different time points up to 5 years of age. Height was the same, so we didn't compromise their height. We didn't turn them into giants either, but they grew like the rest of the normal population. This is their BMI. We also looked at other measures of obesity, skin fold thickness, abdominal circumference. Obesity and failure to thrive rates were equivalent in both groups. Not surprisingly, caloric intake, if growth is the same, caloric intake was the same. We did find, interestingly, that despite the fact that peanuts were being given, which is a high source of protein homeostasis was maintained. So the two groups ate the same amount of protein, and protein homeostasis is very important in growth and development. There was a slight increase in carbohydrates in the avoidance group and a slight increase in fat in the consumption group. So there was a trade-off between fats and carbohydrates because peanuts are rich in fat. So if you're eating more fat to maintain your calories at a certain level, you've got to eat less sugar. So good news is they were eating about 4 grams less of sugar a week, if that has much meaning. Dietitians here can inform me about that. But it certainly didn't cause any nutritional imbalances. In terms of the immunology, I'm just going to really speak about the skin prick test result and allude very quickly to the others. But you see here the different time points in the study where we examined the children. So 4 to 11 months of age was enrollment. 12 months, 1 year of age, we repeated their skin tests and blood. We did the same at 30 months and 60 months. And here is a consumption group on the right. Now, the black lines are the average wheel size to peanut in the two populations. And you can see that it steadily goes up in the avoidance children and remains flat, close to 0, in the consumption group. What you see in the red lines here are the trajectories for individual patients for their skin test size as they move on into the study. And the allergic patients are defined at the end of the study. And then we go back and see what were their skin tests at the beginning, at 12 months, at 30 months. And you see that those red lines, who are the children who became allergic, actually grow very rapidly already between the start of the study and 1 year of age and continue to grow. In the children who followed the protocol and actually ate peanut, only 1 child developed peanut allergy, and that is the trajectory of that skin test in the consumption arm. We were able to switch off high not average IgE levels, but high-level IgE production in the consumption group, which is interesting, and this is something we're further analyzing, particularly now in the context of LEAP-ON. We did cause a big increase in IgG, particularly IgG4 blocking antibodies in the peanut consumption on the right. The role of these IgG4 so-called blocking antibodies is one that has intrigued us for decades, both in the context of immunotherapy, such as peanut oil immunotherapy, and also in the context of prevention. Is this an epiphenomenon? Is this a side player? Or is this a central player in the prevention of peanut allergy? And I think the jury is still out on that one. I'm going to skip this. The important conclusions of this study is that we were able to reduce peanut allergy in both groups, and this prevention was associated with immunological changes. So there are now some consensus communications from various bodies recommending that high-risk children be seen and be evaluated and given peanuts very early on in life. High-risk children being children with severe eczema or egg allergy, as per the LEAP study. I presented thus far a very rosy picture, but so this is Hugh Sampson, who's put all these together. These are the guidelines. But so this is the rosy picture that I showed you earlier. I'm not saying this isn't good, but it's not as perfect as it seems, because if you recall, there were already 76 children in the start of the study for whom prevention was too late. And if you take them into account in the whole population, we were only able to reduce the prevalence of peanut allergy by just over half, which isn't bad, but it would be nice to catch these children before they became peanut allergic. So how do we do so? And one of the questions was, we looked at the populations to see who were the children who became allergic very early on. And what we found was the children became allergic very early on have a red skin test of greater than 4 millimeters. And you see that group grows with age. The later you catch them, the higher the chance of their being allergic already. So there's a narrow window of opportunity to intervene. And on the extreme left, you see that if you get in before 5 months of age, not one of the children has peanut allergy yet in the study. So one of the conclusions would be, well, try and get them in, evaluate them, and start the process of prevention earlier at 4 to 5 months of age rather than 11 months of age. And the EAT study is actually looking all the way down to 3 months of age with earlier introduction. Who should we apply this to? And the team did some modeling. This is not published yet, but one of the things, if you look at the penultimate column on the left, okay, this shows the modeled effects of what would happen to the rate of peanut allergy in a population if you apply the LEAP intervention to various groups. And on the extreme left, you see greater than 40. That's a SCORAD eczema severity score. And if you only apply it to the children greater than 40, and you go up to you see the value 16.12%, that's the amount you would reduce the rate of peanut allergy by only targeting LEAP-like children with severe eczema. And that's a sobering thought, because if we just follow the LEAP criteria, we'll be just scratching at the surface in terms of preventing peanut allergy. To really prevent the whole disease burden in the population, you need to go down to the children with mild eczema, with SCORADs of 1 to 15 in yellow, and there, if you target that population, you'll decrease the rate of peanut allergy on a model basis by about 40%. So our view very much is the intervention should be put out for the whole population of children with eczema, and arguably, and it's something we can discuss later, children without eczema. So, early intervention, and perhaps apply it to all children with eczema, and you might get a better effect. The LEAP-ON study, which we are analyzing now, and I don't have the results for you, but we hope to have published early next year, looks at what happens when we take peanut out of the diet for a whole year. One of the reasons we did that was when we started to see oral immunotherapy studies work beautifully, but the problem was in quite a large proportion when you take egg or peanut out of the diet for 1 or 2 months, the children seem to become allergic again. The question was, would that happen in the LEAP study? If the children who ate peanuts stopped eating peanuts, would they become allergic? And we're looking for that in the LEAP on study. The EAT study, and this is my conclusion now, virtually, is looking at 1,300 children who are normal, not high risk or low risk, but a normal population of exclusively breastfed children. And the question is, if you look at this normal population who are exclusively breastfeeding, and at 3 months of age, you randomize them to continued consumption, to continued exclusive breast milk versus early introduction of peanut, egg, milk, fish, wheat, and sesame, will you, by 3 years of age, prevent the burden of food allergic disease the way we were able to prevent peanut allergy? And this really is looking at the concept of prolonged exclusive breastfeeding as per WHO guidelines, which Michael Perkin and I discovered at our peril early on in this study is a bit of a dicey concept to play with, because people don't like the idea that we might interfere with exclusive breastfeeding by giving foods early. But we did that, and while awaiting the results of this study now, I think the only slide to show here to reassure you is that breastfeeding, and this is in press at the moment, breastfeeding does not change between the two groups all the way up to 12 months of age. So if you take children and introduce solids at 3 months of age, you're not switching off breastfeeding. The mothers continue to breastfeed, which is reassuring. So this is not early foods versus breastfeeding. This is early foods together with breastfeeding versus exclusive breastfeeding. That's a really important concept I'd like you to think about with respect to the EAT study. The findings will be out, and I presented data here on LEAP, not on EAT. I'd like to thank my main colleagues, collaborators, both practically and intellectually. All of these people played a major role, and others. George was my partner in crime in this study, as Michael Perkin is in the EAT study, and of course the LEAP study team, our funders, ITN, MRC, ASMA UK Centre, Food Standards Agency, but most important, the families, because they were fabulous. And out of 640 children, 628 remained with us all the way through till the end of the study. So only 12 children couldn't be seen, mainly because they moved overseas. It was an incredible commitment over 5 years, and we hope to have the results of LEAP on and EAT for you soon. I've overrun my time, but hopefully there's a few minutes left for questions, and thank you for your attention.